Okay, so this is our Chapter 8 notes, starting with 8-1, and we're looking at matrices in this chapter. Now, we're going to be writing matrices in different forms, but let's talk about where matrices come from first. If we have a system of equations with 3 variables here, and we've got 3 equations, or we can look at 4 equations and 4 variables, 5 equations and 5 variables, we can write in what's called an augmented matrix. We have our matrix here, and then what the equations are equal to on the other side of this line right here. Now, our goal in working with matrices in this form is to get them into what's called row echelon form, where we have ones down what we'll call the main diagonal, zeros below. We can have values up here, or they can be 0, and then numbers over here. So we want ones down the main diagonal and zeros below the ones. That's the main point here. So we can use what are called matrix row operations in order to get these matrices in this form. So we can switch 2 rows. They can just switch this row with this row. We can multiply the elements by a non-zero number. So for example, if I wanted, I could multiply this whole row by 5. And then 2 rows can be added together. Now, this is the one that students generally have the most trouble figuring out what that means. So we'll look at an example of what it means to add a row to another row. If I'm wanting to add this row to this row, what that means is I can add 1 to 0, A to 1, B to D, and C to E. And I'm just adding that to that. It doesn't change this row. It only changes the row that's being added to. Okay? So let's go ahead and look at a couple examples here. It says we have this given matrix right here and we want to perform the row operations listed. So what this means is we're switching row 1 and row 2. Now that means row 3 is not changing at all, so I'm going to go ahead and copy it down. And then we're going to switch these 2 rows. So row 1 is going to become row 2. And then row 2 is going to go to row 1. Okay. Now this one is saying we're multiplying row 1 by 1/3. So we're not addressing this at all. We're still staying with the original matrix. But we're multiplying row 1 by 1/3. So 3 times 1/3 is 1. 18 times 1/3 is 6. Negative 12 is going to become negative 4. And 7. And then the other rows did not change at all, so we just copy them over. Okay. Now this last row operation here is telling us that we're going to multiply row 2 by 2, and we're adding that value to row 3. So the only row changing is row 3. So before we do anything else, I'm going to copy rows 1 and 2. And row 3 is going to change here. So 2 times 1 is 2, plus negative 2 is 0. 2 times 2 is 4, plus negative 3 is 1. 2 times negative 3 is negative 6, plus 4 is negative 2. 2 times 5 is 10, plus 6 is 16. Okay? And that's what we were doing there. Now we're going to use these row operations to solve a system of equations. That's what matrices are being used for. We want to solve a system of equations using these row operations with a matrix. So let's look at the example on the next page. Now I've listed some steps for you here that are really helpful. The first thing we want to do is write this as a matrix. So let's go ahead and do that. We have 3, 1, 1. We're just looking at the coefficients here. 1, 1, 3. 2, 2, 2. And then 31, 19, 25. So now we've written it as a matrix. And now we're going to use row operations to get this into row echelon form. So I want ones down the main diagonal and zeros below. Well, I have a 1 right here in row 3, so I'm actually just going to switch rows 1 and 3. And what you'll do every time is draw an arrow here and describe what operation is happening here. So you need to write this every single time, whatever it is that you're doing. So we switched to row 1 and row 3. Row 2 stayed the same. And then row 1 becomes row 3. Okay. Now I've got a 1 right here. And now I want to try and make this a 0. So I'm going to multiply row 1 times -1 and add it to row 2. Actually, you know what? Before I get that 0, I'm going to get this 0 first. I usually try to go off after this 0 first. So I'm actually going to multiply -3 times row 2 and then add it to row 3. Okay. So -3 times -1, or times 1 is -3, plus 3 is 0. -3 times 1 is -3, plus 1 is -2. -3 times 2 is -6, plus 2 is -4. -3 times 19 plus 31 is going to give me -26. And none of the other rows changed. I didn't change any of them, so I'm just going to copy them down. And then to the next one, for row 3, I can actually multiply by -1/2, and that'll make these numbers a little bit nicer. Okay. So -1/2 times row 3. But none of the other rows are changing, so I'm just going to copy them down. And 0, and -1/2 times 2 becomes 1, 2, and 13. Okay. And we're still not there yet. We've got a 0 here. We want these to become 0s, and we want 1s along the whole diagonal. So let's go ahead and keep working on that. What I can do now is I can, let's see, I can multiply row 1 times -1 and add it to row 2. So let me go ahead and write that here. -1 times row 1 plus row 2. And again, row 2 is the only one changing. So I can just copy down row 1 and 3 really quick. Okay. And so -1 times 1 is -1 plus 1 is 0. -1 times 3 is -3 plus 1 is -2. -1 times 2 plus 2 is going to be 0. And we're going to have -6 here. Okay. And from here, I can multiply by -1/2. And again, we always want to describe what we're doing in each step. Multiplying by -1/2, this is going to become a 1, and this will become a 3. And so we're getting closer here. We've got another 0, and now I want this to become a 0. So multiplying row 2 by -1 and adding it to row 3. That will get me that. So I'll copy down rows 1 and 2 real quick. And -1 times 1 is -1 plus 1 is 0. 0 plus 0 is still just 0, and then that's not going to change. And -3 plus 13 is just 10. And then the only thing left is to make this a 1, so I'll just do 1/2 times row 3, and that'll get us there. 1, 3, 2, 25, 0, 1, 0, 3, and 0, 0, 1, 5. Okay. Now what this means here is actually that this is a system. We can put it back in a system. So that was our next direction. Rewrite it back as a system of equations. So now we have x plus 3y plus 2z equals 25. So that's this first line. And then no x's, just one y and no z's. So y equals 3. and then z equals 5. So we've solved for y, and we've solved for z, and now we just need to solve for x. So when I plug those back in, x is going to equal 6. So my answer then is 6, 3, 5. And that's how we want to write our answer. And that's the end of that example. Let's go ahead and look at the next page real quick. Now, in my opinion, row echelon form is not the most efficient to get this into. This is the form I think is the most efficient. And we're using what's called Gauss-Jordan elimination. So not only do I want zeros here, not only do I want ones along the diagonal, now I also want zeros up here. Because what that does is it tells me x is equal to a, y is equal to b, and z is equal to c. So these are the steps. I'll let you read through those on your own, but it's the same steps we were just going through, except for now we also want zeros above, okay? So this is the exact same example we just did. So I'm going to pick up where we left off on this example. So this is from example 2. We left off with 1, 3, 2, 0, 1, 0, 0, 0, 1, and then we had 25, 3, and 5. So this is from our last example. And now I just want to get zeros above here. Well, I've already got a 0 here. And now I can multiply -2 times row 3 and add it to row 1. And doesn't change rows 2 or 3. So -2 times 1 is -2, plus 2 is 0. None of those will affect that. And -2 times 5 is -10, plus 25 is 15. And then one more row operation. We have -3 times row 2, plus row 1. Again, that only changes row 1, so I'm going to copy down the other rows. And let's see, to do that, -3 times row 2, -3 times 1 is -3, plus 3 is 0. That doesn't change, and that 0 is not going to change. -3 times 3 is -9, plus 15 is 6. And that's what we had gotten before. We had x equaled 6, y equals 3, z equals 5. So our answer is 6, 3, 5. And that is our solution to this system of equations. And that's the end of section 1 in chapter 8.